Hello everyone and welcome back to Calc Practice Problem. Today we will be doing a trig function problem, and make sure to like and subscribe. So in this problem we're supposed to suppose that the temperature in Staunton, Virginia in degrees Fahrenheit can be modeled by a sinusoidal function s of t, where t is the time in months since January 1st. Note that, for example, August 1st is 7 months after January 1st. A formula for S of t is as follows. And using this model, what is the coldest temperature in Stanton? All right, so it told us the equation, S of t. And for this equation, we're supposed to find the coldest temperature, or otherwise known as the min. And to find the min, we're going to want to know when that negative term, negative 21 cosine pi over 6t, when that's maximized, since that'll give us the largest value to subtract from S of t. So it's maximized at 1, and there's the values that a cosine function will equal 1. And right, it's just a period, so it's going to continue forever. Basically, it goes 0, 2 pi, 4 pi, 6 pi, 8 pi, etc. till infinity. So we're going to want to find when that's maximized at 1. And to do this, we'll just assume that it's 1. That's all we need to know. So it's 55 minus 21 times 1, or otherwise known as just 21, and that'll equal 34 degrees Fahrenheit. Okay, let's move on to the next one. So we have, using this model, what is the average temperature over the entire year? And to go about doing this, it's probably best to graph this so we know what it looks like. So I went ahead and did that on Desmos. I'll link them in the description if you want to check out their graphing capabilities. But yeah, there's the graph, and it's asking what is the temperature over the entire year. Well, notice how this graph is exactly, it's the same period over and over again. So to find the average value, we're going to want to just know the what's between the max and the min. And you can kind of just eyeball that off of this. That's that line right there. And you can look at the axes, and if it was more properly marked, you could see this a little better, but that would be 55 degrees Fahrenheit. Okay, so that's how you do that graphically. That's how the method I would recommend doing that problem. Question 3, at what time t does the temperature first reach room temperature, 68 degrees Fahrenheit? And I highlighted first because it's a periodic function, so it's going to hit that temperature multiple times. But we just care about the first time. Well, okay. So we have our equation again. And we want to know when that equals 68 degrees Fahrenheit. So then we'll just solve for t from there. So we can subtract 55, and then we can divide by negative 21 to get that. And then from there, we can take the inverse cosine function, otherwise known as arc cosine. So basically, you just switch what's in between the parentheses. So we're switching what's there and what's there, you see, into that, into that. Yep. And so we get that. And then from there, we can solve for t by just multiplying by 6 over pi, and that's t. So it's asking for exact form, but I went ahead and simplify this in my calculator to 4.2749 months. And if you're trying to do that on your own, make sure your calculator is in radian modes, since we're dealing with pi. And for the graph purposes, it's in between 4 and 5, so 4.2749. And I marked that in the purple lines. And you can see how it hits 68 a little bit after 4, as marked there. And yeah, make sure to like and subscribe, and watch the next video.